Greetings, tech enthusiasts. We are delighted to have you here for a remarkable event featuring AWS Amplify with Ali. Ali Spittle, our distinguished speaker for today, is an eminent advocate for AWS Amplify, known for her passion for Python and JavaScript. With a strong desire to share her insights with the community, Ali is the perfect guide to explore the basic backend principles that underpin this transformative cloud development platform. Following this presentation, we will open the floor for a Q&A session, allowing you to ask questions directly from our speaker. And to top it off, we will be awarding certificates to commemorate your participation in this enlightening event. So stay tuned until the end of the event to receive your certificates. Now, without a further ado, I'm thrilled to pass the virtual podium to Ali, who will captivate you with her expertise.
Thank you so much. I'll go ahead and start with my slides. So what I'm going to be talking about is backend development for front-end engineers. And we're going to be using AWS Amplify. I am Ali, and I am the head of developer advocacy, docs, and growth for AWS Amplify. And you can find me everywhere on social media as A Spittle. I get to work every day with Amplify and help make the decisions on what gets built into the product. So I feel very lucky to be able to do that and to be teaching you all about this as well. Actually, this is my first talk back from maternity leave. So this feels really exciting to be back at it, and speaking to a women's college really, I think, is a great venue for this. I had a baby about 9 months ago, and so we're just getting back to it. So the goals for what we're going to talk about today, we're going to chat about the back end and the cloud, and we're going to talk about the underlying services that go into this. We're going to build a backend and build a whole app using AWS Amplify. We're going to do data, we're going to do authentication, we're going to do authorization, and then we're also going to deploy our app. And hopefully you'll walk away with more full stack cloud knowledge than you walked in with. I'm also totally here for your questions at the end, so feel free to leave them in the chat and I will answer as best as I can. And if I can't answer, then I'll ask somebody else and get the answer to you after the fact. So what is the cloud? The cloud allows you to access computer resources on demand. So maybe you used iCloud or Google Drive to store your phone's images so that you have more storage space on your phone. Or maybe you've used Google Drive to share these documents and space on your computer. So these are two examples of cloud services that anybody can use, and many companies use the cloud for their server infrastructure. So what a server is essentially a fancy computer that provides functionality for other programs or devices. So for example, serving web pages, you've probably used this every day, and applications to users via the request response cycle. So when you go to a website, you make a request. So you type in google.com that's saying, hey, Google, I'm making a request to you. And then it'll give you a response, which is the web page. In Google's example, it'll be the Google search page with your search term plugged in. Facebook, it would be your Facebook timeline. So behind the scenes, a server handles that response, and it can handle database queries to get data back, business logic, and more. There are some benefits of using the cloud versus server racks at your company. That's what I did in my early career when I was just starting out as a software engineer. I had server racks that I would maintain and push code to. But now there's the cloud, and there's a lot of benefits for that. So the first thing is that you pay for what you use. So instead of having to, no matter what, pay for all the servers and running the whole data center, you pay for the amount of server space that you use for that month or that billing period. In addition, you don't need to pay for the physical data centers. You don't need to worry about hiring all the people to work at those data centers. It's less expensive to buy servers in bulk rather than individually. So you also benefit from that cost cutting. And in addition, most cloud providers have global data centers. So instead of it just being in the corner of your office, you'll be able to share your data around the world and closer to your customers. It'll also make your app more performant and comply with local laws. So I work for AWS, which is the cloud provider that we'll be focusing on today. It's broken into over 200 services. You may have heard of some of them before, like EC2 or Amazon S3. There's also this whole category of serverless services. AWS Amplify is one of those. AWS Lambda is probably the biggest one. You may have heard of that one. But we'll talk about all of those today. And what serverless does is it does the scaling and server management for you. So that's all abstracted away from you, which is really cool. We will be deep diving on AWS Amplify, which will even further abstract away a lot of the cloud management from you. So if you want to create an AWS account, you can go to aws.amazon.com. What I always do when I create a new AWS account or a new AWS user is create a billing alarm. So there is a free tier, and you can learn all about that at aws.amazon.com/free. Many services fall under that free tier, so you can get started and use them. And I think there's also a special university program as well. I'm less versed on that, but what I always do is create a billing alarm so that I will get a notification if my account goes over like $5 of billing or $10 or whatever I set it to. So I do $10 and I get an email if I go over that. The next thing that I want to talk a little bit about is IAM, which is AWS Identity and Access Management, and it'll help you control access to your AWS resources. You will probably end up seeing this when you create an AWS account, so I just wanted to put it on your radar. So the least privilege principle, you only want to give the least amount of access as possible, only access to what's necessary. So you don't want to just give blanket access to everything in your AWS account. You just want to enable the services that you need. And you also only want to limit that to the actions that you want to be able to take. So you can use existing policies. It's just something that you might see. So I wanted to mention that. So what are the really hard parts of backend development? Scaling, scaling, scaling. So when you go from 0 users to 1 million users, your backend infrastructure historically would look dramatically different. And that's one of the hardest parts of backend development. There's also system design, and that's how much data needs to be stored. How fast does it need to be accessed? Are there long-running jobs? And with any decision, there's going to be trade-offs. There's no absolute right answer whatsoever. There's only pros and cons to different strategies. So let's talk about some considerations you may make when you're adding data to your application. The first one is NoSQL versus SQL. There's also types of NoSQL within there. You also need to model your data. So you need to be able to structure your data in a way that you're going to be able to access it. And then you also, if you're building a mobile app or even a web app, I've had to do this when I was a software engineer, online and offline availability. So does your app need to be available to people just when they're on the internet? Or do you also want them to be able to access things when they're offline? Okay, so let's dive a little bit deeper in each of those bullet points. So SQL stands for Structured Query Language, and When you work with SQL, you're working with what's called a relational database. So you have multiple tables, and the items within those tables can relate to one another, and you can join that data using something called a join. NoSQL stands for not just SQL, and every other type of database falls under this category. And usually you don't have joins. And the benefit with NoSQL usually is that there's lower latency, and uh, your data is going to be less structured than within a SQL database. So this is a diagram of what a join might look like. So you have data in two different tables, and then there's an ID in the first table that shows how it relates to the item in the second table. And you can match up the different items using what's called a join. So in this case, the first table is a shopping history, and each one ties to an item that the person bought. And you could use a join to figure out, okay, this is the person's purchase, and this is what they actually bought. So when you're choosing, usually SQL is standardized and understandable, and everything is relational. NoSQL will tend to be faster to get your data when your application scales and has a lot of data. So it's really good for large amounts of data. But it can be a little bit trickier to learn. I used to teach code full time at a coding boot camp, and it was always a little bit trickier to figure out NoSQL, but these databases are both things that I think are really worthy of learning. For SQL, I would always recommend Postgres. For NoSQL, MongoDB is a huge one, and then we're going to be talking about DynamoDB today. There are different types of NoSQL databases. So for key value stores, each item is stored with a key and a value, kind of like an object or a hash, if you've learned about those in CS classes. Redis is an example of a key value store. Graph store focuses on relationships. So a lot of social media sites use graph stores. So how is data related to one another? For example, a friend on Facebook has a bunch of other friends, and all those friends are related to one another. So a graph store could be used to store those types of relationships. And Neo4j is one of the biggest graph stores. Then there's column stores, and these are sets of columns, and the data is stored really in that column format. Cassandra is an example of that. It's really good for if you're doing like data analysis on a big data set. That's usually when you would use a column store. And then document stores store data in JSON or BSON, which is binary JSON, or XML. And MongoDB is an example of that. We're going to be talking about Amazon DynamoDB here. It's a serverless key value pair document database. So to break that down, it's serverless, which means that you don't need to worry about the server infrastructure. You don't need to add a second server if your application grows, for example. It'll handle all that for you behind the scenes. And key value pair, going back to the last slide, you're going to have a key. And once you go to that key, there's going to be a value associated with it. Again, like a JavaScript object or a Python dictionary. It's highly scalable, and it's a database that's going to scale with you as many users as you need. So Amplify is going to interact with these underlying services for you. So you're not even going to have to think about them, but I wanted to teach you a little bit about what's going on behind the scenes. Okay, so another consideration that you might want to make is, do you need your data online and offline? So if it's going to be offline, you also want to store data both on the device, so on the phone or in the browser, and in the database. And that can be pretty complicated. So there's this theorem in computer science called the CAP theorem. And the CAP theorem says that you can only have 2 out of the 3 between partition tolerance, consistency, and availability. So partition tolerance means that a system continues to run if there are outages. Availability means that every request gets a response on success or failure. And then consistency means that all replications have the same data at the same time. So for an app with a front end, partition tolerance is necessary. So you have a server and a client, which is 2 partitions at the very minimum. We also have stated that we want our data available online and offline. So full consistency is the branch sacrificed and eventual consistency is enacted instead. And Amplify will allow you to have your data be offline and online available without needing to add any additional logic. So I can tell a story of something that I built that needed to be available online and offline. And I used to be a software engineer at Dev2, which is a social network kind of for developers. I would highly recommend it for you all. But what I needed to do is they have a blog post editor, right? So you're writing your blog post. And if you go offline, you don't want to lose your blog post, right? That would be terrible. That would be a lot of work just out the window. So what I did was I wrote code so that your blog post was also stored on your device, so in your browser or on your phone, so that if you suddenly went offline, you weren't going to lose your whole entire blog post. That being said, the blog post was not the same in the browser and in the database if you went offline, because if you went offline, you can't anymore. So we sacrificed consistency so that I can have it be in the browser and in the database and be available even if I go offline. So that's kind of the CAP theorem in action. You can only have 2 out of the 3. You normally sacrifice consistency in this case of online, offline data, and you do that for eventual consistency instead. So at some point, it's going to be the same in the browser and in the database, but maybe not all the time. So AWS Amplify's data store, it's going to store both in IndexedDB and DynamoDB. So IndexedDB is an in-browser, developer-friendly, synchronous data store that stores across browser sessions. So if you've ever used local storage, it's very similar to that. It just can store more data than local storage can. So it's going to sync data automatically between this IndexedDB, which is just in the browser like local storage, and DynamoDB, which is our true database that's storing all of our data, and you don't need to do any extra work for that. Okay, now when we're creating an API, a couple things to think about: serverless versus serverful, GraphQL versus REST, and are you going to use containers? So serverless is going to decrease the administrative overhead and cut server costs. So serverless means that you don't need to handle all the server logic behind the scenes. So if you need, or if you're adding more users, you don't need to add another server yourself in order to scale your application. If you have a server, then say you have 1 million users now and you used to have 1,000, you're going to have to add more and more servers yourself and do that logic yourself. And there's a simplicity behind serverless that you don't need to worry about that. And also from a payment perspective, you're only paying for the number of requests that are used rather than having a bunch of servers just in case you do end up scaling. So some serverless services you may have heard of. AWS Lambda is the really big one. There are also serverless databases. We talked a little bit about DynamoDB, but there's also Aurora, Firebase, and then there's containers. So Amazon Fargate. And more server full services, I guess, Amazon EC2, Elastic Beanstalk, Heroku, etc. So there are also different types of APIs. So an API is how you interact with data. It stands for Application Programming Interface. And there are two de facto standards for APIs over the last decade or so. So REST APIs are the ones that are very, very common. Defines a route for a grouping of data. So if you go to /users, it'll have a list of all your users. Users 1, then it would have 1 user. The downside to this is that you need to have an endpoint for everything that the front-end engineer needs data for. And it needs to be in the format that that front-end engineer needs the data. So you need to manually code all these things. I'm going to skip ahead to a demo, and I'm going to show you how to create a data model with AWS Amplify, and then we'll come back to talk a little bit about what data is created. So I'm in the AWS console. This is what it looks like when you go into AWS. And then if I go into AWS Amplify, then I guess it's just showing a list of services right now, but you can also search for them. So I'll search for Amplify and then click Get Started. Create an app name and deploy it. Once that's done, I can go into the Amplify Studio and create a data model. So I'll say add model. And what I'm going to be building is like a notes app, like similar to Google Keep or the notes app on your iPhone. That's what I'm going to be building a data model for. So when I click add model, I can add one for note, and then there'll be fields for that data model. So in our note example, title and text, and most of those will be string fields. So like in the notes app, you'll have a title for each note and then the actual note itself. Then we'll deploy it, and this will get it deployed into the cloud. And behind the scenes, a database was created. So I don't need to do anything with that. It's an Amazon DynamoDB database. And it's also going to create an API layer for me. So the API layer is going to allow me to interact with my front end and build that out as well. So my front end can talk to my backend data. I'm using a GraphQL API. So GraphQL sends all queries to the GraphQL server. There's no more extra data or having to create new endpoints for every action. So instead of having to create the user's one page or the user's API, I can just send one query to the GraphQL server and it'll give me the data that I asked for back. It's a protocol for sending all those queries to one endpoint. And it's a standard that Facebook created actually for their use cases at first. And I actually started using GraphQL back in like 2016, 2017, and it was like so hard back in the day. But now it is so much easier because you can use managed services to do it. So AWS AppSync is an AWS service that makes GraphQL APIs for you. So you don't have to do anything extra to get a GraphQL API. It will generate the schema for you. And when I created that data model, it created an API for me. So I want to go back in time a little bit now and talk more about what AWS Amplify is. So AWS Amplify is a set of tools that's targeted specifically to front-end and mobile developers. There's a bunch of AWS services behind the scenes that power it. So it's built into the full rest of the AWS world. It's not built with anything different behind the scenes. It's DynamoDB databases, Amazon Cognito for authentication and authorization. It's Amazon S3 for file storage, all of those things. It makes interacting with those services a lot easier for somebody like me who works primarily as a front-end JavaScript developer. So I don't need to know all those different services or know a ton about the cloud. I can just use this one service. So we started out with a command line interface that you can use to provision those backend resources. Have also moved to a more visual interface called Amplify Studio, and we also offer front-end hosting. The next thing that I want to talk about is authentication. So two main things to think about with this is authentication versus authorization and also security. So authentication is making sure that the person says they are who they are. So this is usually done through like password authentication. So when you log into a site, that is authentication. And you might do that with a social provider. So something like having a Facebook profile could make it so that you can log into other websites as well. And you're saying that you are the same person that has that Facebook profile. You could also use a password to do that instead. And authorization is allowing users to do certain things depending on their roles. So I keep using Facebook as an example today, which is funny because I don't really use Facebook myself, but keep coming back to that in my talking today. Authorization is saying, hey, I'm Allie Spittle. That's my user. I can create posts to the Allie Spittle profile, and I can make status updates from that user. But I can't do the same thing on Andrew Bach, that's my husband. I can't do the same thing on his profile. So if I go to Andrew Bach's website or Facebook profile, I cannot write a Facebook status for him. That's what authorization is giving certain users special roles. Certain things to think about when you're implementing authentication and authorization is never store a password in plain text. So you never want to say ABC123 in plain text. You always want to encrypt it. You'd want to use a hashing algorithm to compare passwords and make sure that the users use secure passwords. You don't just want them to say A is their password, for example, or cat or dog or password. You want to make sure that it's a certain number of letters and numbers and characters and all those things. There's also multi-factor authentication, which is really important. Security questions to make sure that somebody really is who they are, say they are. You might want to lock out the account if they ask too many times to sign in and they keep using the wrong password. You also might want to use a CAPTCHA to make sure that somebody is like a real user. So those are some things that you might want to implement with authentication. So Amazon Cognito is what is behind the scenes powering Amplify's authentication, and it allows you to do user sign up, sign in, access control really quickly and easily. And you can enable multi-factor authentication and social auth as well. So social auth, like sign in with Twitter, sign in with Facebook, etc. So Cognito is going to be powering that. And here is how with Amplify you can enable authentication in your app. So I went in behind the scenes and I built out some UI components, which is another thing that you can do with Amplify. You can actually build out a user interface. If you use the design tool Figma, you can build out UI components on Figma and then actually sync them with Amplify and tie your data to UI components. It's pretty fun to work with and pretty cool. But we'll go over to the authentication tab and you can add in email authentication. You could also add in another login mechanism, like say Facebook auth or whatever, but I'll just do the default. Confirm deployment. Once that deployment's done, what I can do is I'll go to my local application. So I was developing in the cloud. Now I'm developing locally. And what I can do is run Amplify pull, and that will pull anything that I do up in the Amplify console down to my local environment. So this is a React app that I built out. It has a front end for my back end. And if we have time at the end, I can show you a little bit more of this process, but I really wanted to focus on the back end for this talk rather than the front end. So I won't go too into it. But again, this is React front end code that I'm using to build out a front end for the data that I created. So what I'm going to do is I'm going to use the with authenticator component from AWS Amplify. I'll wrap my whole application in that. And what that's going to do is make it so that I need to sign in order to access my app now. So first I'll need to create an account. So there's a tab for that. You can see that. And once I sign in, then I am able to view my app. I can also go in and create like a sign out button. I'll skip doing that just because, again, I want to focus more on the back end. But you can do all these things with AWS Amplify. So you saw the notes. If I go back a little bit. Here, all the notes. So those notes are what are correlating to that data model that I created. So in the data model, I had a title for each note and then a body. So in this case, I have the title and then the body displayed on my user interface. And again, AWS Amplify helps me to do all of this. And then I added authentication with Amplify as well. The next thing that I'll do is add authorization. So again, authentication is making sure a user is who they say they are. Now, with authorization, I'm going to add rules for what certain users can do. So I'm going to go back to my data model. And in here, I can add authorization rules. So right now, anybody who's signed in can create, read, update, and delete notes. So anybody can perform any action on my data. I can change it so that an owner is the only person who can do certain actions. So in the case of a notes app, maybe you want to have a bunch of different people be able to see notes, but only the person who created the note can update it or delete it. But even further than that, you might want it to be really like the Notes app on your iPhone, where the owner is the only person who can even read the notes. And so that's what I ended up doing. So the owner, the person that created the note, can perform all actions with it. Nobody else can do anything with those notes. So if I created a note, I can do all the things to it. Otherwise, I'm pretty much locked. So I just deploy that. I run Amplify pull that pulls all these changes into my local application. And then again, I'm in my React code on the front end here. And what I can do here is, again, with, so I'm using this data store, which is this offline online data sync. So when I'm signing out, I'm like clearing out my data store so that it's not persisting in the browser anymore. So that's what I'm doing right there. Signing in. And now I don't have any notes. So none are showing up. But then if I do create a note, then it does show up. So only the ones that I own now are showing up on my application. So I can interact with the ones that I create, but all those other ones that I had in the last step, that collection of notes, I can't see anymore because my user didn't create them. So just like that, I can create authorization rules for my application. I don't even need to add any extra code. I just add it directly through Amplify. So one other key piece that you may need for your application is file storage. So file storage is needed when you need to store bigger files. So things like images. You can't store them in your database because your database isn't going to be good at getting that. It's too much data. So instead, you store a link to the image and then your image itself in an Amazon S3 bucket. It's called object storage. So this is another thing that you can implement with AWS Amplify. So you'll have a storage bucket with a bunch of images in it, and then be able to query for those images, display them on your page. The last thing that I want to talk about is deployment. So now I have my application front end. I have my one note that I personally created, and so it still shows up on my page, but all those other things don't. So I'm going to create a GitHub repository for my Notes app. I'm going to push my app to GitHub. And once it's on GitHub, I can use AWS Amplify to deploy it. So I'm going to create a hosting environment. I'll use GitHub since I created a GitHub repository. I'll authorize it. I'll choose a branch and a repository. And set up a service role. So that's that IAM service role that I talked about at the beginning. Add some permissions and review them. Again, that's an IAM role. And then I'll save and deploy. Once it's done building, my app will be deployed to the world and anybody can access it as long as they have the URL that I send them. So that's what I have to do to get my app published and out into the world. So front-end deployment, that's how that works. And Amplify automatically deploys your backend for you. So I don't even need to do anything to do that. My backend is already deployed. So something that you might need to implement when you're deploying a backend is CI/CD, which is continuous integration and continuous delivery. So what this generally looks like is I'm going to keep adding code to my front end app, right? And once I do that, I want to redeploy my app front end. Sometimes I'm going to want to make sure that I'm running testing on my front end. For example, at work, we have like a spell checker that always runs on our code to make sure that everything is spelled correctly before it goes up to the public or to GitHub. I can do those things through AWS Amplify as well. So whenever I make a commit to my main branch on GitHub, I can redeploy my front end, making sure that it passes all these tests first. And do automatic front end redeployment. And same with my backend too, as I can add CI/CD, and also maybe on my backend, also on my front end, I might want to enable pull request previews. So every time that I deploy a new front end feature and make a pull request on GitHub, I might want to see what that pull request ends up looking like when it's merged in. I can do that through Amplify as well. You also might want to have different environments for production and development. You can also do that with Amplify as well, so that you can work with multiple people and at multiple stages of development. Okay, I feel like I threw a lot of information at you all. So I am here to go back through anything, answer any questions that you have. In order to learn more about Amplify, I always recommend the docs. So docs.amplify.aws. And again, if you want to get in touch with me at any point, I'm A Spittle everywhere on social media. So reach out. I'm a little bit slower at responding to DMs and things like that because, again, just had a baby and I'm trying to work more reasonable hours, but I'm there and here to help you as much as I can. Thank you so much. And again, now I'm here to answer your questions.
Okay, thank you, Ali. And as we near the culmination of our event, it's time to engage directly with our speaker. So please go ahead and type your questions, and we will make sure that all of them are addressed right now.
I do see a couple from a few minutes ago. So one question is SQL not good for a large amount of data? And that's a really good question. So there's two types of scaling: horizontal scaling and vertical scaling. And different types of databases are good at different things. So NoSQL databases are better for horizontal scaling, and SQL is better for vertical scaling. So just something that you want to think about as you work through these things. So for example, for SQL, you could put like your different database tables on different servers. Whereas for NoSQL database, you would be able to add servers even more easily than that. So yes, usually for a very large amount of data, it's going to be faster to get it out of a NoSQL database and easier to store all that data and have it be truly serverless. So you don't have to manage the servers yourself. But then again, a lot of the world runs on SQL. So that's not like a bash on SQL or anything like that. It's just something that you might want to consider. Oh, I saw a question about pricing too that popped up on the bottom. And I'll address that. So there's a pricing page. So for most of Amplify, you actually don't pay for Amplify itself. You just pay for the underlying resources. So you pay for like DynamoDB, but not Amplify itself. The one area that you do pay for Amplify is hosting. So it's pay as you go. It's like 1 cent per build minute. Then there's some storage costs as well. You can find all of that at aws.amazon.com/amplify/pricing. And it's also free tier eligible. So you can try it out for free for the first year and up to a certain amount of resources. Does AWS Amplify web hosting support private Git servers? So you can do like a private GitHub repo for sure. And there are different Git providers that you can use, but I don't think a private Git server necessarily would work, but you can always upload your code as like a zip file as well and access it and deploy that way too. Where can you find the latest news on AWS Amplify? Great question. The two places that I would show you are docs.amplify.aws. So that's the documentation site. And that'll have really in-depth information about everything. But if you want to hear about launches, we have a front-end web and mobile blog. And the URL for that is aws.amazon.com/blogs/mobile. And that will have all the launch announcements and news and all that. Yeah, okay, so the Amplify console and how is that different from Amplify Studio? So Amplify console is everything Amplify that exists in the AWS console. So the AWS console is like the AWS website once you've signed in. It's where all the services are and all that. So everything that is Amplify that exists within that site is the Amplify console. Amplify Studio is part of that. Amplify Studio is specifically for creating backend resources. I know it's a little bit confusing that we've named all these things different things. There should just be one Amplify, and that's something that I'm working on. But yeah, Amplify console is the everything that exists within the AWS console. Amplify Studio is part of that. It's the part for making backend resources and also doing Figma to code. How is AWS Amplify related to the AWS mobile SDKs for iOS and Android? So Amplify is built on top of the SDKs for iOS and Android. So they're highly, highly related to one another. Amplify just has this extra like abstraction layer away from the SDKs, but both are related to each other, I would say. How does hosting with AWS Amplify relate to Amplify's open source framework? So Amplify hosting is the front-end hosting portion that I showed, and you can use that to deploy any front end with like React, Next.js now, Vue, Angular, whatever front end you build with front end resourcing, you can deploy that with Amplify's front end hosting. And then Amplify is kind of the name for all of these different services for front end developers. And one of those things is the Amplify framework, which is libraries that allow you to interact with your backend resources from your app's front end. So libraries that connect your backend to your front end, basically. That is fully open source, and the Amplify command line interface is open source as well. Amplify's hosting service is Amplify Hosting, and you can find that within the AWS console. How do you get started with Amplify Hosting? So there are a couple of tutorials that you can follow. There's actually like a marketing page for hosting, and on there is a couple tutorials. So aws.amazon.com/amplify/hosting. There is a tutorial on there that has like how to get started with hosting. There are a bunch of different tutorials that are out there. Depending on what you want to host, the instructions are going to be slightly different. So I would look up a tutorial for whatever platform you want to host, especially Next.js is going to be a little bit different. Can we begin our backend development journey using AWS, or do you need some sort of prerequisites? So with Amplify, you don't need to have any backend knowledge to work with it. So you can definitely start your backend development journey using AWS Amplify. The one prerequisite you would need for Amplify is knowing some sort of front end. So whether that be JavaScript or React, or you could do iOS or Android or Flutter for a mobile app. Those are all different options there. Can you use the Amplify libraries even if you don't use the CLI? Yes, great point. So if you create just an Amazon S3 bucket yourself, you already have one that exists, you can still use the Amplify libraries to connect to that Amazon S3 bucket, display your images on the page, for example. Or you could, if you have like an Amazon Cognito instance set up for your authentication already, you can use the Amplify login forms to connect to that Cognito user pool. All of that are things you can 100% do with Amplify. You can use all these different things either together or all together. Yes, AWS for sure supports REST APIs. AWS Amplify does, and then AWS as a whole. So if you wanted to do a REST API, you can use API Gateway natively, or you can use Amplify to create one. What we do under the hood is create a AWS Lambda function for you, and then you can create an Express API, for example, with REST. I also have a tutorial that's out there how to do it with Flask for Python. So there's a bunch of different supported languages that you can use. I think like .NET is another one. So yes, you can definitely create a REST API with AWS and AWS Amplify.
Okay, so I think we have answered almost all the questions. Thank you, Ali, for sharing your valuable insights and expertise with us today. Your passion and knowledge have truly enriched this event, and we are grateful for your contribution. Thank you once again.
Thank you so much. This was fun.
Okay, so now is the moment we've been waiting for, certificates. So if you attended the event and would like to receive a certificate of participation, please scan the QR code on the screen and fill the feedback form. Okay, thank you everyone for being a part of this event. We hope you found it informative and engaging. Your presence and participation are truly appreciated. Thank you.